Hello everybody, we are going to talk about growth, linear growth versus exponential growth. This might be something you've already heard about recently. We've been talking about flattening the curve so much. That curve, when we're talking about coronavirus and how many people are going into hospitals, that curve can grow exponentially. So let me show you the difference. First of all, a linear growth, linear line, right? If it was graphed, it kind of looks like this, or maybe like this, or more like that. Either way, those are all pretty straight lines. But exponential growth, if we're talking about graphing that, exponential growth would look like this. It increases a little bit at first, and then it really starts to increase quickly. When we've been talking about flattening that curve, we've been talking about flattening the curve of people that could potentially be admitted to hospitals, right? Because if all of a sudden, a couple people go to the hospital and then, several more and then hundreds are going at a time, unfortunately, there's just not enough healthcare workers to take care of people. So we've been trying to stay home, of course, to get the curve to look more like this rather than like this. So that's something that is very applicable to real life right now, right? You guys always ask me, it's a great question. Well, when am I ever going to use this stuff? Well, right now. So let's talk about the difference in terms of the worksheet. It's a pretty quick section. So let me tell you a little bit more. Linear growth increases by the same absolute amount. Increases by the same absolute amount. We're going to do examples and we'll show that, but I want to get the definitions out first. When we're talking about exponential growth, it increases by the same percent. Okay? Linear is an absolute amount. Exponential is always a percentage. So if we're talking about the population grew by 2% for 5 years, we're talking about exponential growth. If we're talking about I made 20 cents more an hour this week and I make another 20 cents more an hour next week, that's an increase of 20 cents each week. Then we're talking about linear growth, okay? These are important definitions, and those are the ones you'll need to know to do this section. So let's look at the first question. The first question is, the population of a city is increasing at a rate of 3% per year. If the population is 100,000 today, what will it be in 3 years? So first of all, is that linear growth or exponential growth? It has to be exponential growth, right? Why? Because it's increasing at a rate of 3%. You see a percentage, automatically you're thinking exponential growth. We're not saying we're increasing by 500 people each year. With population, that doesn't really make sense, because the more people you have in a city, right, the more growth you're going to have. If you have 100 people in a city versus 1 million people in a city, and both of those cities are growing, right, it makes more sense that the city with 100 might add another 50 people, and the city with 1 million might add another, 100,000 people. They're not on the same scale. So again, anytime you see percentage, we know automatically we're talking about exponential growth. So after year one, if it's growing by 3%, what's the population after year one? Well, I can just take this, multiply it by 3%, and then add that to this, and I'll get that. So 100,000 times 3% equals 3,000. So the population after year one is 103,000. So what about year two? Do I just add 3,000 again to this and we get 106,000? No, right? That would be linear growth. But now I have to take this number, right? It's relative to, the population change is relative to the year before. So I'm going to multiply those together. I can't do this one in my head. And I get 3,090. So now I take this and add them together, and I get 106,90. See what I did there? So the first year it increased by 3,000 people. The next year it increased by 3,090 people. All right, what about after year 3? I do the same process again. I take the population from year 2 and I increase it by 3%. So I say this plus this number will equal this number. I got 3,182.7. That's fine. So when I added those together, I got 109,272.7, or about 109,273. Just watch for what my math up, how they want you to round to the nearest tenth or to the nearest integer. Remember, integers 0, 1, 2, 3, -1, -2, they don't include decimals. They don't include fractions. Exponential growth can increase things very, very quickly over time. Remember when we did those problems with the retirement? Remember how in just the difference of 5 years, when you did the written assignment, that's what I'm talking about. If you didn't do the written assignment, you don't know what I'm talking about. But remember when I said, okay, now start saving 5 years later, and you lost a huge amount of money. That's because those are exponential growth. And once you get into those big amounts of money, cutting off only 5 years, some of you lost $200,000, $300,000 when you just started saving just 5 years later. So something to think about. Exponential growth can increase things very, very quickly. And that's the same thing we were talking about with coronavirus. If people start spreading this disease all over the place, the amount of people that may have to go to the hospital could increase very, very quickly. Let's look at number 2. The price of gasoline is increasing by 4 cents per week. If the price is $2.10 today, what will the price be in 10 weeks? So they're saying 4 cents every week. Well, we can say, okay, it's $2.10 now, but we need to add 4, that's not how you write 4 cents. Bad teacher. 4 cents for a total of 10 weeks. So I can multiply this. Okay, we know that's 40 cents. And the price will be $2.50. You could also just add 4 cents 10 times. It just takes a little bit longer. What kind of growth is that? Of course, that's linear growth, right? It's changing by the same absolute amount each time. If we modeled that, if we actually graphed that on an XY coordinate system, you would get a straight line. All right, what about number 3? Go ahead, read through it. Hope you guys are all doing well. Number 3 is very similar to which one? Number 1 or number 2? Number 1, right? Instead of the population increasing, though, the value of the car is decreasing. So if the car is worth $12,000 today, and it's decreasing by 10%, what will it be worth in 2 years? Well, after year 1, it'll be this minus 10% of this, right? So 10% of that is $1,200. So after year 1, it's this minus this, or $10,800. And then after year 2, it's 10% of this number now. So 10,800 times 10% will give me $1,080. So I say this minus this, and I get year 2, which is $9,720. Again, this is exponential, not growth, but exponential decline, right? After the first year, the value changes by this amount of money. But then after the second year, the value changes by less because the car is worth less, right? And this is a real life situation. After the first year, your car decreases in value quite a lot. It actually decreases quite a bit in value when you drive off the lot, right? If you buy a brand new car. But the older your car gets, well, the less money it's worth, so the less money it has to lose. Good. And what about number 4? The value of your house is increasing by $2,000 each year. This is not really a good real life example, but it's hard to find a lot of these, I think, with linear change. If you guys have a good linear example, let me know, because this one, not as great. Usually house values increase by percentages, which would be exponential. But this one, they're saying the value of your house increases by $2,000 per year. Well, if it's worth 220,000, today, what will it be worth in 6 years? Well, 2,000 times 6 is another $12,000. Remember, this is the $2,000 times 6 years. And we'll just add them together to get to $232,000. That's it for 8A. Your next section will be 9A, and I'll get that video posted pretty soon. If you have any questions, please send me an email. Let me know how you're doing. We have about 2.5 more weeks to go, guys. Then we are done. I know you're looking forward to it, but push through. I lose some people now, and I don't want to lose you. So keep pushing through. And again, if you have any questions, just let me know. I will talk to you soon.